The SSC Tuatara, specifically in its projected and evolved 2026 model year iteration, represents not merely an automobile, but the absolute zenith of hypercar philosophy, a machine that exists as a crystallized ambition to redefine the boundaries of mechanical possibility, where the pursuit of velocity is intertwined with advanced aerodynamics, cutting-edge material science, and a ruthless focus on driver-centric performance. To understand the 2026 Tuatara is to delve into a narrative that begins with its record-shattering lineage and propels forward into a future where its design and engineering are honed to an even finer, more lethal edge, incorporating lessons from its now legendary status as the world's fastest production car. The very name, derived from a species of native New Zealand reptile known for its rapid regenerative capabilities and unique evolutionary path, is a metaphor for the car itself, a creature built to adapt, to evolve, and to thrive at the very extremes of the environment it is designed for, which is not the jungle, but the lonely stretches of asphalt where the only true competition is the immutable laws of physics. The exterior design of the 2026 Tuatara is a masterclass in form following function, sculpted not by a whimsy, but by the invisible hand of computational fluid dynamics, and countless hours in the wind tunnel, resulting in a shape of haunted beauty, a brutal efficiency. Every contour, every vent, every surface transition is a dialogue with the air it slices through. The front fascia is dominated by a low, wide stance, with intricate LED headlight strips that are as much a signature visual element as they are aerodynamic aids, channeling air around the front fenders. The massive central intake feeds cooling to the front radiators, while the pronounced carbon fiber splitter, likely more aggressive and refined for the 2026 model, works in concert with the underbody to generate significant downforce while managing airflow towards the rear, its edges sharp enough to seem capable of cutting the very air molecules themselves. The dihedral synchronous doors, a hallmark of hypercar theater, open upwards and forwards, revealing not just an entry point, but a technological statement. Their precise hydraulic movement a prelude to the cockpit within, moving along the profile. The silhouette of the 2026 Tuatara is its most defining characteristic, a teardrop shape honed over nearly a decade of development, a shape inherently stable at speed. The roofline arcs smoothly from the steeply raked windshield over the single-piece carbon fiber monocoque tub that forms the car's core structure, flowing seamlessly into the elongated tail section, a feature critical for high-speed stability. The side intakes are not merely stylistic. They are gaping maws that force-feed air to the mid-mounted engine, their channels sculpted deep into the bodywork, often finished in exposed carbon fiber to highlight their functional purpose. Behind the doors, just ahead of the rear wheels, additional vents exhaust high-pressure air from the wheel wells, reducing lift. The side skirts are carefully shaped to manage the airflow along the underbody, accelerating it towards the rear diffuser. The wheels themselves are bespoke, center-locking forged alloys wrapped in Michelin Pilot Sport Cup Tour tires, specifically developed to handle the Tuatara's colossal power and speed, with optional carbon fiber wheels likely available to further reduce unsprung mass. The brake calipers, monstrous units from brands like Brembo or AP Racing, clamp down on massive carbon ceramic discs, a necessity for a car capable of such devastating acceleration and required to shed that velocity. With equal authority, the rear view of the 2026 Tuatara is a complex, layered landscape of aerodynamic artistry. The full-width, razor-thin LED taillight is an elegant bar of light that spans the width of the car, sitting atop a rear fascia dominated by function. The active rear wing, a work of aerospace-grade carbon fiber, is a multi-element device that can adjust its angle and height in milliseconds based on driving conditions, providing both downforce for cornering and reduced drag for all-out top-speed runs. Beneath it, the twin-turbocharged V8 engine is visible through a polycarbonate window, a jewel on display. Below that, the rear diffuser is a sprawling, multi-channel carbon fiber labyrinth that works to suck the car onto the road by accelerating the airflow underneath it, its vertical fins preventing lateral airflow disruption. The exhaust outlets are likely to be a center dual or quad setup, finished in titanium or Inconel to handle extreme temperatures, emitting a sound that is a blend of a traditional American V8 roar and the forced induction whoosh of its twin turbos. The entire rear assembly is a testament to the fact that at this level of performance, beauty is a direct byproduct of engineering necessity. There is not a single element that does not serve a purpose in the management of air, heat, or power. Stepping inside the 2026 Tuatara via those dramatic dihedral doors reveals an interior that starkly contrasts with the race-bred exterior, a sanctuary of focused luxury and minimalist design. This is not a cabin of wood and chrome, but of carbon fiber, Alcantara, titanium, and fine leather, all arranged with a driver-centric purity. The cockpit wraps around the occupant, with every control falling readily to hand. The steering wheel, flat-bottomed and hexagonal or square in shape, is reminiscent of a Formula One car, devoid of most buttons to keep the view of the instruments clear, and is likely trimmed in Alcantara with contrast stitching. Behind it lies a fully digital, reconfigurable instrument cluster, a high-resolution screen that can prioritize different information, from a minimalist speedometer to a complex array of telemetry data, including boost pressure, oil temperature, lateral g-forces, and even lap times. The central console is dominated by a touchscreen interface that controls the climate system, infotainment, and vehicle dynamic settings. While its design is intentionally subdued to avoid distracting from the task of driving, the seats are fixed back, carbon fiber racing buckets, padded and upholstered in the finest leather and Alcantara, providing exceptional support during high-G maneuvers. The pedals and steering column adjust to fit the driver, a necessity given the fixed seating position. The use of carbon fiber for the monocoque means the interior structure is visibly woven in places, a constant reminder of the car's racing-derived construction. Sound deadening is minimal by luxury car standards, as the engineers want the driver to hear the mechanical symphony of the engine and transmission, but it is sufficiently insulated to allow for conversation at highway speeds. The overall ambience is that of a bespoke instrument panel for a spacecraft, where luxury is defined not by opulence, but by the exquisite quality of materials and the singular purpose of the environment to connect the driver to the machine and the road with absolute fidelity. The heart of the 2026 SSC Tuatara, the source of its earth-shattering performance, is its engine. It is a 5.9-liter twin-turbocharged flat-plane crank V8, a masterpiece developed in partnership with Nelson Racing Engines. This configuration is significant. A flat-plane crankshaft allows for quicker revving and a more exotic, raspy exhaust note compared to the traditional cross-plane V8 as common in American performance cars, aligning the Tuatara more with the high-strung character of European hypercars. The engine is dry-sump lubricated, a critical feature for maintaining oil pressure during extreme cornering. It features precision-forged internals connecting rods, pistons, and the crankshaft itself to withstand the astronomical forces involved. The twin turbochargers are large, fed by an intricate system of charged coolers and piping, and are capable of delivering immense boost pressure on standard pump gasoline 91 octane. This engine produces a mind-bending 1,350 horsepower. However, the true party trick and a key feature that would be carried over and refined for the 2026 model is its ability to run on E85 ethanol fuel. The higher octane and cooling properties of E85 allow the engine management system to advance timing and increase boost further, unleashing a staggering 1,750 horsepower. This dual-fuel capability showcases an engineering philosophy that seeks every possible avenue for performance. The power is transmitted to the rear wheels via a computerized 7-speed automated manual transmission, or CIMA transmission, developed with specialists like CIMA, or possibly updated to a newer, even quicker shifting unit for 2026. This transmission can operate in both automatic and manual modes, with shift times measured in milliseconds, delivering ferocious, neck-snapping gear changes that are felt physically by the occupant. The management of this colossal power is handled by a sophisticated suite of electronic aids, including traction control, stability control, and a complex torque vectoring system, all adjustable through multiple driving modes that range from a more manageable street mode to an all-out track or max velocity mode that optimizes every parameter for ultimate speed. The chassis and suspension of the 2026 Tuatara are as advanced as its powertrain. The core is a monocoque tub made entirely of carbon fiber, providing immense rigidity and safety while keeping weight phenomenally low. The total dry weight of the car is estimated to be around 2,750 pounds, giving it a power-to-weight ratio that defies belief. This tub forms a safety cell for the occupants, with integrated side impact structures and mounting points for the crash structures at the front and rear. The suspension is a fully independent system utilizing unequal length control arms, likely with pushrod or pull rod actuation of inboard mounted shock absorbers, a layout borrowed directly from racing cars for optimal geometry control and packaging. The shocks are electronically controlled, allowing for adjustable ride height and damping stiffness. In a street mode, they can provide a surprisingly compliant ride, absorbing bumps with a level of grace unexpected in such an extreme machine. Flick to track mode and the chassis tightens, the ride height lowers, and the car transforms into a razor-sharp tool. With minimal body roll and instantaneous response to steering inputs, the steering itself is electrically power-assisted, providing precise feedback and variable weighting, communicating the limits of adhesion at the front tires with exquisite clarity. The integration of the aerodynamic elements, the front splitter, underbody channels, and active rear wing means that the chassis capabilities are enhanced by downforce. That grows with speed, literally pressing the car harder into the pavement. The faster it goes, increasing cornering loads to levels that can exceed 1.5 lateral G-forces. This marriage of lightweight construction, race-derived suspension, and active aero creates a driving experience that is simultaneously immense in its capability and accessible in its feedback. The car feels alive, communicating every nuance of the road surface, yet inspires confidence by being remarkably stable and predictable at its limits. Limits which are so high they exist in a realm few drivers will ever fully explore. The performance figures for the 2026 SSC Tuatara are not just numbers. They are statements of intent that border on the apocalyptic. The aforementioned 1,750 horsepower on E85 fuel, channeled through a car weighing less than 1.25 tons, results in acceleration that redefines visceral. While official 0 to 60 miles per hour times are often conservative, the Tuatara is capable of achieving this in under 0.0 seconds, a sensation often described as being fired from a cannon, where the horizon seems to rush towards the windshield with violent immediacy. The quarter-mile disappears in the mid to high 8-second range at trap speeds exceeding 180 miles per hour. But acceleration, while brutal, is merely a prelude to the Tuatara's ultimate claim to fame, its top speed. The current generation Tuatara has already verified a two-way average top speed of 295 miles per hour, with one run exceeding 300 miles per hour. The 2026 model, with potential refinements in aerodynamics a slightly high, or drag coefficient for stability, or lower, one for pure speed, tire technology, and engine calibration, would be engineered to not only touch, but reliably exceed the 300 miles per hour barrier. Achieving such velocity is an exercise in systems management. It requires a transmission with extremely long gearing, tires specifically developed and certified to spin at these rotational speeds, without disintegrating, and aerodynamic stability that becomes paramount as the car becomes a wingless aircraft, sensitive to every crosswind and pavement imperfection. The braking performance is equally staggering, with the carbon ceramic system able to haul the car down from 200 miles per hour to a standstill in a distance that seems implausibly short. The immense aerodynamic drag acting as an additional brake at triple-digit speeds, the experience accompanied by a firm, unwavering pedal feel and no discernible fade. The technological ecosystem of the 2026 Tuatara extends beyond pure mechanics into sophisticated software and connectivity. The vehicle dynamics control system is a network of sensors, monitoring wheel speed, steering angle, yaw, lateral and longitudinal, acceleration, and even the position of the active aerodynamic elements. This computer brain makes constant, imperceptible adjustments to the traction control, stability control, and torque vectoring to keep the car on its intended path, intervening only when it detects a deviation beyond the driver's control. Multiple drive modes such as wet, sport, track, and VMAX velocity maximum reconfigure these systems, along with throttle response, transmission shift speed and aggression, damping stiffness, and exhaust note. In VMAX mode, for instance, the suspension likely lowers to its minimum ride height, the rear wing retracts to a minimal drag angle, the engine cooling vents may close, and all stability aids are set to a threshold that allows for ultimate speed while maintaining a safety net. The infotainment system, while secondary, would feature modern amenities, Bluetooth connectivity, Smartphone integration via Apple CarPlay and Android Auto. A premium sound system, though often considered superfluous given the engine's soundtrack, and perhaps even a telemetry system that can record lap data via integrated GPS. The car might also feature a comprehensive vehicle health monitoring system that can relay data to SSC's headquarters for proactive maintenance. Ownership of a 2026 SSC Tuatara is an experience that begins long before taking delivery. Each car is essentially bespoke, with the buyer working directly with SSC's design team in Richland, Washington, to select every detail from the exterior paint color, which can be virtually any hue, with complex multi-layer finishes, pearlescence, and exposed carbon fiber accents to the interior material palette, types of leather, Alcantara colors, stitching patterns, and metal finishes. This level of personalization means no two Tuataras are exactly alike, each being a reflection of its owner's taste. The production process is painstakingly slow, with each carbon fiber monocoque being laid up by hand, each engine being assembled and bench tested by specialists, and final assembly being more akin to watchmaking than traditional automobile manufacturing. The delivery process is an event, often involving extensive orientation from SSC's technicians on the operation of the car's complex systems. Ongoing ownership is supported by a white glove service model, giving a limited production likely fewer than 100 units total for all Tuatara variants. SSC provides direct, personalized support. Maintenance is a specialized affair, requiring trained technicians and specific tools, often involving the car being transported to a specialized facility or having SSC fly a team to the owner's location for scheduled service. The community of owners is exceptionally small and exclusive, often gaining access to special events, high-speed track experiences, and a direct line of communication with the company's founder, Jared Shelby. In the broader context of the hypercar world, the 2026 SSC Tuatara occupies a unique and rarefied space. It is an American challenger that has not only matched, but surpassed the established European aristocracy from Bugatti, Koenigsegg, and Hennessy in the single metric of top speed, the most primal and celebrated benchmark. However, it is more than a speed record holder. It represents a different philosophy, less about opulent luxury and more about a pure, almost scientific pursuit of performance. Using the combination of American engine building prowess, the monstrous boost-happy V8, and cutting-edge international technology, the carbon fiber tub, advanced aerodynamics, and electronic systems, it proves that a small, passionate company from Washington State can compete on the world's highest stage. Driven by innovation and a relentless will to prove itself, the 2026 model would be the evolution of this proof, a refinement that addresses any minor shortcomings of the initial production cars, incorporates newer technology in materials and electronics, and solidifies its reputation not just as a record breaker, but as a fully realized, usable, and devastatingly capable hypercar that can transition from a civilized boulevard cruiser to a world-ending speed weapon at the turn of a dial. It is a car that exists at the farthest frontier of automotive engineering, a testament to human ingenuity and the eternal desire to go faster, to push harder, and to build machines that transform the driver, however briefly, into the fastest human being on the planet. Its legacy is already being written in the record books, and the 2026 iteration serves to inscribe that legacy in permanent ink, a symbol of what is possible when ambition is given form in carbon fiber and alloy.